Hot take. For a lot of retrieval systems, buying a GPU first is how teams waste money and still ship a slow product.
Yes. In RAG, retrieval is often much lighter than people assume. The first bottleneck is usually indexing choices, chunking, latency from network calls, or bad re-ranking decisions, not raw GPU compute.
So if I am building search for docs, tickets, or internal knowledge, you are saying CPU is not the embarrassing starter option?
Not at all. CPU can handle classic keyword search, BM25, metadata filtering, hybrid retrieval, approximate nearest neighbor lookups, and even a lot of vector search at modest scale. Those jobs are often memory and indexing problems before they are GPU problems.
Give me a concrete case, because this is where people get sold fear. They hear embeddings, vectors, semantic search, and suddenly think they need a gaming rig under the desk.
Picture a support bot over 50,000 help center chunks. You generate embeddings offline once, store them in a vector index, then serve top K retrieval with metadata filters like product, language, and date. On a decent CPU box, that can feel totally fine for real users.
Fine is a dangerous word. Users do not grade on a curve. Where does CPU hold up, and where does it start to lose?
CPU holds up well when your corpus is small to medium, your traffic is moderate, and most requests are just query embedding plus retrieval. It also works when you can pre-compute document embeddings and only embed the incoming query at runtime.
But query embedding is still model inference. That sounds like the point where the clock starts screaming.
Sometimes, small embedding models can run acceptably on CPU, especially if your latency target is not ultra-tight. If your app can tolerate, say, a few extra tens of milliseconds, CPU may be good enough. The key is to measure the full request path, not panic over one component.
So, when does the GPU actually change the game, instead of just looking impressive on a diagram?
A GPU helps most when you need high-throughput embedding generation. Low-latency query embeddings at larger traffic, or heavy re-ranking. Re-rankers, especially cross-encoders, can improve relevance a lot, but they are much more expensive than the initial retrieval step.
That sounds like the hidden power shift. The team that adds re-ranking wins quality, but maybe loses simplicity and cost control.
Exactly. Initial retrieval narrows the field. Re-ranking reads query and candidate text together and scores them more intelligently. Great for quality, expensive for compute. If you re-rank 20 or 50 candidates per request, GPU can become the difference between crisp and sluggish.
Give me another real scenario, not theory. A programmer is about to choose architecture this week.
Say you built an internal code assistant over 1 million code and docs chunks. Nightly document embedding is taking hours on CPU, and daytime traffic now spikes because every IDE query hits semantic search. Add a re-ranker on top, and CPU starts queuing requests. That is a clean moment for a GPU.
So the GPU is not for virtue. It is for a specific failure mode: throughput, latency, or quality under load.
Right. If users are waiting, backlogs are building, or you cannot afford to skip re-ranking anymore, GPU earns its keep. Before that, it can distract you from simpler wins like better chunk boundaries, better filters, caching, or reducing candidate set size.
Let me push on that. Why do so many systems not need a GPU at first, if everyone talks like semantic retrieval is computationally brutal?
Because early systems are usually overbuilt in the wrong place. They have small corpora, low query volume, and lots of easy relevance gains available from data hygiene. Better titles, metadata, deduplication, chunk overlap, and hybrid search often beat throwing hardware at a weak pipeline.
So the losers are the teams that optimize compute before they optimize retrieval logic.
Yes, and there is a strategic cost. If you assume GPU from day one, you may choose bigger models, more moving parts, and more operational complexity than the product actually needs. That slows iteration, and iteration is how RAG systems get good.
Let us make this practical. If I'm starting from zero, what can I confidently run on CPU without feeling naive?
Start with document preprocessing, chunking, metadata extraction, sparse retrieval like BM25, hybrid retrieval, vector indexing, vector lookup, and small query embedding workloads. Also run evaluation on sampled queries so you understand relevance before you scale hardware.
And the warning signs that tell me the CPU phase is over?
Query latency is missing your budget. Batch embedding jobs are too slow for your update cycle. Re-ranking is clearly improving quality, but crushing response time. Or traffic is growing enough that CPU scaling is becoming more expensive than adding a GPU path.
One more example, but make it painful. What mistake do teams make here?
A team launches a legal document assistant. They buy GPU capacity early, use a large embedding model, skip hybrid retrieval, and never tune filters by jurisdiction or date. Relevance is mediocre, costs are high, and users still cannot find the right clause. A smaller CPU-first pipeline with good retrieval design would have beaten it.
That is the twist. The expensive stack can lose to the disciplined stack.
All the time. Retrieval is a systems problem, not just a silicon problem. The fastest way to a good answer is often better indexing and ranking strategy, then hardware, only when the measurements force your hand.
So the real question is not, do you need a GPU for retrieval? It is, what part of your retrieval pipeline is actually hurting you right now?
Exactly. Use CPU until the numbers say otherwise. Bring in a GPU when embeddings or re-ranking become the bottleneck. In RAG, the winner is not the team with the most hardware. It is the team that knows which milliseconds matter.